Good morning, everyone. My role today is very brief. I'm going to introduce the topic and then turn it over to Sam Francis, who's a member of the ICC Tollwood Building AdHoc Committee. Many of you are familiar with Sam. He's going to explain very carefully the outcomes of the work of that committee. I have another role today also, and that's to try to keep Sam moving and on schedule for our hour and a half, or what'll be about an hour and 15 minutes once he gets going. And here's the course description, which you've already seen, and the learning objectives. It's all about the committee, the new construction types that are being proposed, the size limits of the buildings, and then the particular fire resistance characteristics of these buildings, since the focus is on taller. We're doing so. Let's do the first. Let's find out who is here today, and I'll turn it back over to Brian.
The first poll question is, what is your profession? A, architect, B, engineer, C, building code official, D, fire code official, or E, other? I'll give just a few more seconds for people to answer here. All right, I'm going to close out the poll window now, and let's share the responses. So we have 8% reporting in as architects, 59% engineers, 22% of our audience are building code officials, 4% are fire code officials, and we have 7% as other.
All right, very good.
Back to you.
Yeah, very good, thank you. Welcome, everyone. Here is our outline. I'll take the first leg. Sam will get into the next one. But here's the question today, really. What has actually changed in wood construction? Why is it that we're talking about mass timber? Why are we using that term now? And why are we talking about tall wood buildings? Well, here's the star of the show, so to speak. Cross-laminated timber is the product, and it's a new product because, and many of you are familiar with it, but I bet you're familiar with it through attending classes or seeing articles or presentations about it. Few of you, if any, have seen it actually on the construction site. That's because right now we have very few producers in the US, but you will begin seeing it very soon. So what actually is it? It's actually dimension lumber, such as 2x6s or 2x10s, laid up side by side to form solid wood layers that are alternating in orientation of the lumber in the layers, and it's connected with adhesives. You can see it a little better in this close-up photo here, all forming a massive slab of timber, which will be used as solid timber walls, floors, and roof slabs, this one being set here, typically between 6 and 12 inches thick, but can be thicker. And the one shown in the previous slide was a 7-ply CLT slab, about 10.5 inches thick. So they're prefabricated, solid timber slabs that are brought to the site and put into mass timber buildings. And I love this photograph of engineers with Lend-Lease Corporation actually setting one of these CLT panels or slabs on the top of the facility, the test facility, on the top of the CLT structure that was tested at the Bureau of Alcohol, Tobacco, and Firearms. So just a little information about the development of CLT. It is a new product. The important part of the information on this slide is that it really came into use not until after the turn of this century, so in the early 2000s, and its development was driven by environmental advantages of building with wood, carbon sequestration, sustainability, it's a renewable resource, and certain construction efficiencies, better weight to strength ratios, and so forth. There are already over 500 CLT buildings in England, by the way. Far fewer in the US so far. So back to my original question, what's changed actually? Why this topic? Why the ICC Tollwood AdHoc Committee? Well, because of CLT, we have a new type of construction that's vastly different than either conventional frame or traditional heavy timber construction. Conventional frame shown on the left in this graphic, conventional heavy timber in the middle. If you have solid timber wall, floor, and roof slab characteristics, that is characteristic of mass timber buildings on the right, these building elements have strength characteristics that are far different than the other two types of construction. Therefore, its utility in buildings of greater height is obvious. And also, the fire resistance characteristics of mass timber are going to be different. Intuitively, the fire resistance of mass timber wall or floor slabs that are protected with gypsum are going to be much different than the repetitive member light frame assemblies. The earliest testing, or one of the earliest tests conducted of CLT for an exterior wall confirmed that the fire resistance is very different. Was one layer of type 5/8 inch gypsum on a 3-layer, or I believe a 5-layer CLT panel, achieved a 3-hour rating. So you can see how that's very much different than typical light frame or even typical traditional heavy timber. And that test, by the way, is the reason that cross-laminated timber was introduced into exterior walls of type 4 in the 2015 IBC. But the traditional building size and limits in the building code are based on conventional frame or traditional heavy timber, not mass timber. So thus it is that, again, given the comparison we have, it was thought and it's believed that new construction types are appropriate with new parameters, new limits, something that fits mass timber, and this product in particular with solid timber, mass timber walls, was needed. So I'll let Sam talk about the formation of the ICC AdHoc Committee in response to this, but first we're going to go ahead and take a, Sam, you already have the control apparently. I can't advance this slide. There we go, thank you. Let's do this poll and then I'll give it to you for good, Sam. Brian?
All right, cross-laminated timber is primarily intended for use in which type of construction? A, light wood frame, B, post and beam, C, mass timber, or D, all of the above? And just a few more seconds and I'll close the poll out. All right, here we go. And let's take a look at the results. Nobody selected A, 1% selected B. Looks like the winner is C for mass timber, and 22% selected D, all of the above. Paul?
Yeah, very good. I want to, it is correct that the mass timber was the correct answer. Let me remind people though that cross-laminated timber can certainly be used in the lower construction types, type 3, 4, and 5, but its capabilities and the work of the ICC Tollwood AdHoc Committee are really, that comes to full effectiveness in the new mass timber construction types that they're proposing. So that's the reason for this question. You all got the idea. So now I'm going to give it to Sam, and he's our National Programs Director for the American Wood Council and intimately involved with and a member of that committee, and he's the best one to explain these provisions. So Sam, it's all yours.
Thank you, Paul. I should have mentioned before I left that Paul's right, that the product cross-laminated timber is permitted to be used in type 3, 4, and 5 in in various parts of the structure. And in fact, since it's considered heavy timber in the 2018 code, the hearing was in 2015, the code was 2018. Since it's considered heavy timber, there are uses in types 1 and 2 where it can be configured. However, Tallwood Ad Hoc Building Committee is what we're here to talk about. The ICC board established this ad hoc back in 2015, frankly, at the request of the American Wood Council. We actually made the request much earlier. It went on for quite a while. The committee was appointed in December. The ad hoc committee was created to study the science of tall buildings of wood construction, look at the data, look at existing examples, and if convinced, take that information and create code change proposals. So the ad hoc itself consisted of representatives from building construction materials industries, building and fire code officials, architects and engineers, fire protection experts, and other scientists, researchers, and related stakeholders. The chairman appointed 4 work groups: definitions, fire, structural, and codes, and invited the 18 members of the ad hoc to write down what they considered to be the major issues that needed to be examined. Remember, our charge was to look at the building science, gather data, do whatever we needed to do to determine if anything else should happen. So it would be science-based. 82 major issues were identified. I was lucky enough to be on the codes work group, and we inherited about 63 of those 82. Not a well-balanced distribution of major issues. Funny how that works. We reviewed reports. We reviewed data, research from other people. That's from other countries on other continents. And we had presentations for the Tallwood Ad Hoc. And finally, before we got deeply into the data collection and so forth, we had a discussion of performance objectives. What were we going to do? And we identified performance objectives to be met. No collapse under reasonable scenarios of complete burnout. Complete burnout of the fuel source without automatic sprinkler protection being considered. No unusually high radiation exposure from the subject building to adjoining properties. No unusual response of the subject building from typical radiation exposure from adjacent properties. So it should neither transmit nor receive or behave adversely under the normal kinds of exposure. No unusual fire department access issues, internally or externally. Egress systems designed to protect building occupants during design escape time with a safety factor. And highly reliable fire suppression systems to reduce risk of failure during reasonably expected fire scenarios, and some degree of reliability proportional to evacuation time. Specifically, our biggest concern, and that which we heard from most people about, height. and lastly, risk of collapse. It's important to note the Tall Wood Building Ad-Hoc Committee has determined its comprehensive package of proposals meet these performance objectives. The TWB believes that all of those performance objectives that I just read off are met by this package of proposals. So let's get busy and take a look at some of this. And before we do, much of the work that Tall Wood Building Ad-Hoc Committee did is predicated upon testing, and among other things, after we reviewed tests by a lot of people, researchers in private industry and in universities around the world, we knew we needed to do our own set of tests. And so the fire work group of TWB created a fire test scenario, two-story condo, a full scale test, 30 by 30 foot interior dimensions, corridor and stairs included. And most importantly, the fuel load was going to be what has come to be known as the UL modern furnishings kinds of furnishings, though particularly polyurethane foams and other plastic materials that represent high fuel heat content, such that we intended to achieve 570 megajoules a meter squared as our fuel load. The number originally came from tests that AWC did back in 2015, where we used the 95th percentile of fuel loading for Group R based on surveys done in North America. And so the 95th percentile embraces a lot of that. So we settled on 570 megajoules. It's not quite the 95th percentile, but it is the mean plus one standard deviation or a little better. So the fire work group created this fire test set of scenarios. You see in this table 5 tests. These outcomes and the program today are predicated, and we had hoped that you all would have availed yourself of the fire test webinar that was a couple of weeks ago, and the adhesives webinar also a couple of weeks ago. But since we all have real jobs and other commitments, I'm going to review much of it right now. That's why you're seeing the test scenarios. Here's the plan, the building plan. This was full scale, you see. So this is a real life example. It's a 1-bedroom condo and 2 stories. The purpose of which, and there's a corridor around it and a stair connecting the 1st and 2nd floors, both of which were fully instrumented. In fact, we collected, I believe, 420 channels of data. There's a huge amount of data. If you're a geek and you want to look at that stuff, the report is available on our it's the mass timber, awc.org/tall mass timber website. That report's available. Look at it. Lots of discussion about all that data. It's an inordinate amount. So in a perspective here, you see panels of CLT constituting walls and floors, but on both the 1st and 2nd floor, there's a center bearing wall, and we used a beam and columns of laminated timber, which is all large enough to qualify as mass timber, so that we had all of these kinds of mass timber, and we had different connections that we looked at in that configuration. So the size, the occupied space is 30 by 30. The kitchen and living room side is 15 by 30. Bedroom bath side 15 by 30. Ironically, later on I'm going to mention the NFPA FPRF tests that were done at NIST. And one of the reasons that our size was chosen to be this is because the FPRF tests were 15 by 30, so that there's some correlation we could draw. Everything in that compartment complies with the IBC or code proposals that the tall wood building AdHoc is putting forth. That's an important consideration. For example, there's a 20-minute door from the dwelling unit into the corridor, a 90-minute door at the end of the corridor into the stairwell. All of those issues are dealt with. At one point, we put OSB on top of the non-combustible floor as a floor finish, so that the fuel loads and so forth are all replicated. Okay, so this is a slide from one of the before the test. This actually is test number 2, but who's counting? The important thing is down here in the lower right, you can see all of that lovely polyurethane and plastic furnishing, table, chairs, all of that. And in order to keep the fuel load high, if you look carefully, you'll see wood cribbing. You can see it in here as well, in the middle slide, wood cribbing in order to increase the density to maintain the high fuel loads. And before I leave this slide, we'll talk about concealed spaces later on. You'll notice in here that gypboard is applied to the mass timber ceiling, and then the soffit in the kitchen is framed up with non-combustible material. That'll come into play down the road. Here's the bedroom side. So fire test number 1, all the mass timber surfaces were protected with 2 layers of 5/8 type X.
Sam, you're going to go through the 5 tests here. Sorry to interrupt. You may need to pick and choose which details of each test just to keep us moving.
No worries. Here we are at this is test 1. There's the 23 megawatt fire when both the bedroom and the living room have flashed over. And in the bottom right, you see fuel was consumed. There's nothing left but ash and soot. It was allowed to run without intervention by people or sprinklers for 4 hours. That's what was left. And you'll notice the gyp is still attached. Fire test 2 was one where the ceiling was partially exposed. So, and I failed to mention earlier that on that website, Tall Mass Timber, at awc.org/tallmasstimber, you can find video of all of these tests. In fact, you can find the entire fire test presentation that we did a couple of weeks ago. But I do want to run, this is fire test number 2. You can see the exposed ceiling right there. There's instrumentation trees there and back there. Kitchens involved, the living room about to flash over. Living room has flashed over. The flames have migrated to the bedroom. It's about to go. I'd like to leave it on this for a moment because you get to watch the off-gassing in those urethane mattresses. But let's move ahead. So the bedroom, not yet. There it is. Now we're all flashed over. So in each of these fires, the fire itself at its peak was somewhere between 21 and 23 megawatts. It was allowed to burn itself out without any intervention, no sprinklers, no people, as you can see occurring here. And I'm going to advance to the end so we can get through, because I need to get to the end without spending too much time on these things. By the way, it was loaded with water barrels on the upper level in order to generate the full expected live load. There's the exposed ceiling before the fire. Here are the excerpts from that video I just showed you, including some close-ups here of those exposed portions of mass timber. And before all of this started, the Research Institute of Sweden, known as RISE, had gathered data from a number of sources, including that test that many of you are familiar with that was conducted at NIST on the behalf of FPRF. They had lots of data, and they've created a model. Given our information about the test assembly, their model predicted for heat release rate, the solid black line here. The blue line is what we measured at ATF. This is for test number 2. That's pretty fair correlation. They also modeled ceiling gas temperature, and here the black line is the model, the blue line is the observation, and except for a little deviation down here, it's excellent correlation. So here is that room. This is the bedroom side. That's the kitchen over there with the exposed ceilings. There's that beam and column after that huge fire that you saw with the gypsum removed. So there's the exposed ceiling. We took, frankly, we just chainsawed a slice out of that panel. And this is on a kind of weird angle because, frankly, it's laying in the bed of one of our pickup trucks after we cut it out. The char down here is the first lamination of the CLT. There's the second lam, third lam, fourth lam, and up there at the top is the fifth. A little better view is pure sideways. Unfortunately, on the ride home from Beltsville, Maryland, it knocked some of that char off. You know, this is the same piece with the char that's been removed by highway oscillation. And as you can see, the first lam, the char proceeded almost through the first lam. Here's the second lam, third, 5 lam system. Okay, fire test number 3, similar to 2, only this time the walls were exposed. The exposed walls were, so these are the openings. The cameras are all set up out here. You're looking in. The outside wall of the living room, the outside wall of the bedroom. This interior partition, remember, is the column and beam partition, and those the spaces were infilled with non-combustible, in other words, light gauge steel studs and gypboard. So test 3 was run, flash over both sides. The fire continued to the decay phase, and of course, with the exposed walls, they became involved in the fire, as you can see here. But as the decay proceeded, you'll notice that that flame simply diminishes, and our test instrumentation would suggest that it continues as far as self-extinguishment, but that's a whole nother topic. Test number 4 was, okay, let's expose everything, ceilings and walls, but let's put a sprinkler in there. What happens? Will a sprinkler system be able to keep up? Here's our test chamber, lots of instrumentation, as you can see. Fire's lit, sprinkler goes off, and this, whoops, I'm sorry, the lower, come on, get back here. There's the damage after the fire, after the sprinkler system extinguished it. It wouldn't have been that bad, except that ATF uses a gasoline-soaked rag in a kitchen cabinet with, and then they close one of the 2 doors. It's a protected fire, so the sprinkler can't get immediately at it. So it's kind of an interesting phenomena that so little damage was done, even in the case of a protected fire. Fire test number 5, fully sprinklered, all mass timber surfaces fully exposed. But what if somebody accidentally turned a valve off and the sprinklers didn't work? What happens if all that mass timber gets involved in the fire? So what happens is, and for this test, it was decided that we would install glazing in these openings. So there's 3 panels of glazing, living room side, bedroom side, and the corridor door was left open in order to generate sufficient amount of oxygen. But then it wasn't growing at a great rate, so at about 17 minutes, the fire service took a pike pole and knocked out the glazing panel here on the lower right-hand side. So the fire then took off. It got flashover in the kitchen. It was right at scientific flashover. We had defined it, the engineers from FPL and from ATF had defined flashover as 600 degrees at 4 feet from the ceiling. More than 2 thermocouples had to register that amount. So anyway, it was near flashover in the living room and in the bedroom. So the net, let me back up one here. The fire grew quite large. The sprinklers went off, but they were delayed for 20 minutes after the first sprinkler head would have gone off. The lab valved off the water to those sprinkler heads. 23 minutes after the first head would have gone off, it was permitted, and the result was it extinguished the fire, even though, remember, this was all exposed mass timber, no protection of any kind, and it was allowed to get a pretty healthy start up to around flashover. So there's the event log for all 5 tests. Things happened pretty consistently. All of this information is available on the website if you want to peruse it. So having reviewed that, a poll, if you will, Brian.
All right. Which of the following is not one of the tall wood building ad hoc performance objectives? A, no collapse under reasonable fire scenarios. B, no unusual fire department access issues. C, egress systems protect occupants during escape. Or D, occupants protected without leaving the building initially. I'm going to go a couple more seconds and going to close it out now. Let's take a look at the results. Looks like most people are leaning towards D, occupants protected without leaving the building initially. What do you say, Sam?
Occupants protected without leaving the building initially was not one of the AdHoc's performance objectives. Okay, so let's look at the types of construction that came from the IBC Tallwood AdHoc Committee's deliberation. 15 code change proposals. We wound up deciding that 3 new types of construction made sense, and as a result of new types of construction, there would be new entries for height in feet, height in stories, area, and then a whole passel of other requirements for safety, including safety during construction. I left that a little quickly. I wanted to point out that the fire work group had a subcommittee to look at exterior wall tests. Currently, NFPA 285 is required in 1405 for exterior walls, and for a variety of reasons, it was determined by them that the requirement would stay with NFPA 285. Okay, so the first thing that had to happen was we created some definitions, and like everything else that the work group worked on, or the AdHoc worked on, this changed over time. So we had to go back and fix some things, but here are the definitions. First one is mass timber. That's solid built up panelized or engineered wood products that meet the minimum cross-section dimensions of type 4 construction. Non-combustible protection for mass timber. This is non-combustible material in accordance with 7035, designed to increase the fire resistance rating and delay the combustion of mass timber. And then we had to add this in because in Table 601, some requirements are for load bearing, some for non-load bearing, so you need to know which is which. And it was determined to add mass timber in definition number 2. The old wood always fell here under definition number 1, a wall that supports 100 pounds per lineal foot of vertical load in addition to its own weight. Mass timber got added into number 2, masonry concrete or mass timber wall that supports more than 200 pounds per lineal foot of vertical load in addition to its own weight. And you'll see that the AdHoc drew other comparisons to masonry and concrete. So we have primary structural frame got modified to accommodate mass timber. Secondary members got modified here in item 3 to accommodate the mass timber. These are proposals. When I say got modified or the table changed, I'm talking about the current existing proposals in G108 that's on the table and the ICC Group A process. So the AdHoc looked at this and said, hey, look, that we see, looking at all this data from around the world and hearing various presentations, that there are basically 3 kinds of mass timber buildings. There's this type, which is where the mass timber is completely protected with non-combustible protection, which provides 2/3 of its required fire resistance rating for building elements in Table 601. There's we called that 4A. Then 4B is mass timber with portions of that type A protection omitted. 4B is like 4A, but unprotected areas are permitted. There are limits on how much can be exposed and limits on how close various exposed areas can be one to another. Then there's 4C, with no requirement basically for non-combustible protection except certain features I'll touch on later. So got ahead of myself, so here we go. Here's table 601. And frankly, after listening to presentations, looking at research reports and studies from around the world, the Tallwood AdHoc Committee said, hey, except for the issue of combustibility, mass timber is combustible, type 1 construction is not. Except for that, the performance, mechanical, fire, and so forth, is the same. So let's talk about type 4B as being equivalent to type 1B. And so when you look at the fire resistance ratings required, they're exactly the same all the way down. 1B and 4B. So the next logical step was to say, what about 4A? Okay, let's just set it equal to 1A. And we did. So you see the fire resistance ratings all the way down are equivalent to 1A. Then heavy timber is what used to be type 4. It's still heavy timber. That stayed the same. So type C needed to be something else. We simply assigned it exactly the same fire resistance ratings as type 4B. So 4B and 4C have the same fire resistance rating requirements. Table 602, bearing in mind that the 4B, 1B relationship, we went to the table here, 602, and said, okay, wherever 1B appears, we'll add 4B. Wherever 1A appears, we'll add 4A, as is the case in these two lines. That was the basic, that was a very basic premise that from which all of the Tallwood building ad hoc work sprang, that 4B was equivalent to 1B, except that 4B is combustible material and accommodations need to be put in place to accommodate that particular aspect. All right, so other important features, each type of construction is based on test conditions in that fire test that we looked at back there at ATF. The test plan was developed by the Tallwood Building Fire Work Group. The test plan included various generic connections that were recommended by the structural work group to be tested in that. I think there were 7 generic kinds of connectors in that test. And lastly, both panel mass timber, CLT, and other mass timber, glulam beams and columns, were tested. So the first thing in the product of the ad hoc is do no harm to the existing heavy timber requirements. The old 602.4, which was just heavy timber, became 602.4.4 in the new scheme and is called type 4 HT. The intention is to do no harm to that. It stays the same now as it was in the past. Mass timber elements have non-combustible protection. Mass timber elements shall have a fire resistance rating shown in table 601 and 602. CLT elements shall be tested and labeled for heat performing adhesives. That's built into the code language, and in fact it led to a change in the product standard PRG 320. You're welcome to go to our website and watch the seminar on adhesives to learn all about the fire testing and background of the 2 tests now required for all elements that must be tested and labeled for heat performing adhesives. And lastly, all building elements, load bearing and non-load bearing alike, must be mass timber or non-combustible. no combustible light frame construction, nowhere, no time. So here's the proposed text, the actual language submitted by the AdHoc. And I'm going to just scroll through here pretty quickly. Here's the existing language at the top on heat performance, and currently it refers to section 6.1.3.4 of DOC PS1. But the AdHoc has an amendment, a proposed amendment, because of the work that the industry did, coming up with 2 new tests that better define heat performance, and that we'll propose to substitute that in here, but it'll be part of the requirement that it's tested and labeled for that. Exterior load-bearing, non-load-bearing walls shall be mass timber or non-combustible. Interior building elements, including non-load-bearing walls and partitions, shall be mass timber or non-combustible construction. Nowhere does it permit light frame. I'm sorry, combustible light frame construction. Concealed spaces are not permitted except as otherwise indicated. We'll come to that. In the high-rise buildings, exit enclosures and elevator hoistways may be mass timber or non-combustible. Remember, in 403, high-rise is a building with a floor level 75 feet or more above the lowest level of fire department access. In type 4A, or in buildings of height permitted by 4A, is really what that should say. Exit enclosures and elevator hoistways must be non-combustible construction. So in the tallest of the buildings, we're contemplating exit enclosures and elevator hoistways must be constructed from non-combustible materials. Here is that spelled out in language. Okay, we have 3 types of construction, 4A, 4B, 4C, that are being proposed to be added to 602.4. And in 4A, this is the highest form, all mass timber must be protected, interior and exterior. Non-combustible protection must constitute 2/3 of the required fire resistance rating, but not less than 80 minutes in the interior and not less than 40 minutes on the exterior. Floors must all have a minimum of 1-inch non-combustible material on top of the mass timber. So not 2/3 of the non-combustible protection time. If you take a look here at bearing walls in 4A, that's 3 hours. 2/3 of that is 2 hours. And in the Tallwood AdHoc proposal 722.7.1, fire resistance rating of a building element in table 601 or 602, 2 hours means a minimum non-combustible protection time of 80 minutes. Interestingly enough, if you look at the next table, type 5/8, a 5/8 type X gyp board is assigned a protection time of 40 minutes. We'll also submit, by the way, a modification to change this 1/2-inch type X from 30 to 25 so as to be consistent with an entry that already exists in another place in the code. It's unlikely to be used, but 40 minutes, the 5/8 type X is common. And so it's ironic that the 40 minutes turns out to be exactly 2/3 of an hour. What that means is for every hour of fire resistance rating, you need one more layer of 5/8 type X gyp board. Okay. Type 4A exterior wall. There's our wall section. Of the vertical elements and exterior walls have to have a 3-hour fire resistance rating, 2/3 of which have to come from non-combustible protection. 2/3 of 3 is 2 hours. 2-hour fire resistance rating. 120 minutes is 3 layers of gypsum. And more importantly, in that section, the outside face of that wall, the mass timber shall be protected with non-combustible protection with a minimum assigned time of 40 minutes. All components of the exterior wall covering shall be non-combustible material except water resistive barriers having, and it spells out the special characteristics for the water resistive barrier. It's taken straight out of 1405. So here's the definition of exterior wall covering: a material or assembly of materials applied on the exterior side of exterior walls for the purpose of providing a weather resistive barrier, insulation, or for aesthetics, including but not limited to veneers, sidings, exterior insulation and finish systems, architectural trim and embellishments such as cornice soffits, fascias, gutters, and leaders. Everything on the outside, outboard of that water barrier must be non-combustible. This is the code language. The rest of it, there's the interior protection time, the floors. So back to that drawing, the outside has to be covered, has to be non-combustible. After it's everything outboard from the mass timber and that water resistive barrier applied to it. So there will be the mass timber and the non-combustible protection, that 5/8 type X, a water resistive barrier, and then insulation, cladding, and so forth. Everything outboard from there, non-combustible. Roofs have to have non-combustible protection on the inside or the underside. Concealed spaces are permitted, but no exposed combustible material other than that which would be allowed in plenums in the case of type 1 construction. Here's the language. I'll just call your attention here. Concealed spaces shall not contain combustibles other than electrical, mechanical, fire protection, or plumbing material and equipment permitted in plenums in accordance with 602 of the International Mechanical Code. Combustible construction forming concealed spaces shall be protected in accordance with 602.4.1.2. That's the one back there that tells you that I need 2/3 of the 3 hours for vertical, and the floor in a type 4A is a 2-hour. So I need 2 layers of gypsum protecting it. Shafts are permitted in accordance with 713 and 718. Both the shaft side and the room side of mass timber elements shall be protected in accordance with 602.4.1.2. So remember back at the beginning, I pointed out the framing for that kitchen soffit and its light gauge steel. So there are 2 layers of gyp on the ceiling covering up the mass timber, and there's a concealed space formed by non-combustible material. The concealed spaces are an important consideration. It's a way to get mechanicals, plumbing, electric, and so forth distributed in a room, and a way to get it distributed floor to floor. So let's look at 4B. 4B is the same as 4A except for a couple of things. It's got the exterior is the same 40-minute requirement. The interior is the same except unprotected portions are permitted. The floors have the same 1-inch requirement. The roofs have the same protection. Concealed spaces have the same must be protected requirement, and shafts have the same requirement as 4A. So what's the exterior protection? Well, that's that 40 minutes that I mentioned, one layer of 5/8 type X in the prescriptive path. Interior faces have to be protected except where permitted, and there's more about that to follow. Floors have the same non-combustible. So here's in a type B, here's our exterior wall, but now that wall is a 2-hour fire resistance rating. And that means 2 layers of 5/8 type X on the inside. And remember, all of them, 4A, 4B, and 4C, have 1 layer of 5/8 type X required on the outside. Everything after that water resistive barrier over the gypsum, over the mass timber, everything outboard of that has to be non-combustible. Everything. So we have roofs having also having to have protection on the underside. Concealed spaces are permitted with the same materials permitted, and combustible construction forming concealed spaces have to be protected in accordance with 602.4.1.2. Shafts are permitted, and both the room side and the shaft side of mass timber has to be protected with that non-combustible protection. In other words, this is 4B where some exposed is permitted, but it can't be a wall common to a shaft, or you'll see later, occupancy separation. Okay, what is that permitted unprotected area? We can do 4 things. Everything has to be protected with the following exceptions. Unprotected portions of ceilings, 20% equal to 20% of the floor area, or 40% of the floor area as unprotected walls, or portions of both walls and ceilings in accordance with this section. And then number 4, so you have to do 1 or 2 or 3, and in all cases, number 4 applies. Mass timber columns and beams which are not integral to the walls or ceilings respectively shall be permitted to be unprotected. So you do 1 or 2 or 3, 4 always applies. And how do what is that number 3? Well, here's how I determine how much of each I can have. This is, if you don't recognize it, stolen straight from the non-separated mixed use sum of the ratios equation. It's simple. The ceiling area divided by the allowable maximum ceiling area plus the wall area divided by the maximum allowable wall area. The sum of the ratios must be equal to or less than 1. Straightforward. There's a couple of other caveats on that. For example, if you have a little bit of ceiling and a little bit of wall, there has to be a 15-foot separation between them of protected portions. If you have 2 ceiling areas unprotected, there needs to be 15 feet of separation. Okay. Type C. Basically, all of it can be unprotected, with the caveat that exterior walls on the outside have to be protected. 1 layer, 5/8 type X, that's the 40-minute non-combustible protection. The floors only need to meet the interior finish requirements. Concealed spaces must be protected, and no exposed combustibles other than those allowed for a plenum. And shafts must be protected both inside the shaft and on the room side with non-combustible protection of 40 minutes. In other words, 1 layer 5/8 type X. So here's the exact language of what I just said. The outside gets the 40 minutes. Interior, you can do the sum of the ratios, floor finishes, and roof coverings. So on our 4C wall, this can all be exposed. No requirement for protection. On the outside, 1 layer 5/8 type is the actual requirement is non-combustible protection of 40 minutes and a water resistive barrier. And outboard from those, then it must all be non-combustible. So here on 4C, where you don't have to protect anything on the inside face, you have to protect everything on the outside face. Concealed spaces in 4C are similar to those in 4A and B in that combustible construction must be protected. Even in 4C, shafts must be protected both in the shaftway and on the inside wall. And there's our drawing again of non-combustible construction forming a concealed space, no exposed material permitted. So here you go. A new poll. Brian, if you'd be so kind.
Okay, here we are. Which of the following are proposed new types of construction? A, type 4A, type 4B, and type 4C. B, type 4 heavy timber. C, types 1, 2, and 3 heavy timber. Or D, all of the above. Give about 4 more seconds and I'm going to close. And here we go. Let's take a look at the responses, and looks like everybody's leaning towards A, types for A, B, and C. Sam?
And the answer is A. Okay, so we're down to 2 topics, fire protection and building sizes. I'm going to race through fire protection and talk a little about building sizes. We have quite a number of individual proposals built in for fire protection. Some of you may be familiar with the term super tall buildings. There's a requirement for water supply redundancy in what's called super tall buildings, those greater than 420 feet. And the Tallwood Building AdHoc Committee decided to add these mass timber buildings greater than 120 feet to that requirement. So the enhanced water supply kicks in at only 120 feet for mass timber. There's a performance method for determining non-combustible protection. I mentioned the table in 722.7, but in 703.8, there's a performance method. 722.7 is the prescriptive, and what we didn't look at is the page and a half that follows those 2 tables that we looked at, which give installation instructions, fastener schedules, panel stagger, so that the seams don't line up, and so forth. There's mandatory sealing of mass timber elements where splices or intersections occur. And in types 4B and 4C, the mass timber element that also is part of an occupancy separation must have a thermal barrier of 1/2 inch of gypsum. Here's the water supply that I mentioned, buildings of 4A and 4B that are greater than 120 feet in height. You got to have that. Here's the performance version of non-combustible protection. And I know that at least one manufacturer has already explored this. In a nutshell, you take an assembly of mass timber, complete with finishes and so forth, and you test it in an E119 test. You take the same assembly, as it says here, identical in construction, loading, materials, and other than non-combustible protection. You test it, and the second time you add the non-combustible protection that you're interested in, you test it again. Then you take the fire resistance time that you got using the E119 method in test 2 with the protection, and subtract from it the time that you got in test 1 without the protection, bingo, that's the fire resistance time assigned to that particular protection. And the protection has to be fully defined in terms of configuration, attachment, joint sealing, whatever you did to it in the test, it has to be completely described so that installers will do that in the field. Other items, sealing of adjacent elements. So in the code, it's proposed that these splices of panels where panel edges come together, or intersections such as where that floor panel lays on a wall panel, have to be sealed. Those seals can be sealants conforming to ASTM C920 or adhesives conforming to D3498. Quick note, in E119 testing, panels have to have an intersection in the piece that was tested. We did an E119 test on a 5-layer system that had a single layer of gypsum applied to it, and it had a shiplap joint in there, and that shiplap joint had the D3498 adhesive applied to it. And by the way, we got 3 hours and 4 minutes in that test. With respect to that sealant, then periodic special inspections will be required of the sealant or adhesive. So that'll go back in the special inspections section. The fire resistance, that's a straightforward. Of course, in the IBC, it says right in the front of Chapter 7, all fire resistance rating is based upon E119 test concepts. But there are 7 methods of determining fire resistance, and in the case of mass timber, in the front of Chapter 7, the National Design Specification for Wood Construction, NDS, is referenced, and Chapter 16 has, among other things, a calculated fire resistance section. So one can do that. One can look at an E119 test. There are you can go to an accredited agency, like go to UL and look in their directory. Minimum protection, these are all concepts I've touched on. There are the requirements. This is the prescriptive non-combustible protection back in 722.7. But as I said, there are complete details on fastening, offsetting panel edges so that the joints don't line up, how far apart, how screws need to be staggered so that each layer is fastened in a different place, so on and so forth. The same thing applies back there for exterior surfaces. In addition, in the fire code, there's a section on owner responsibility, and this will add in the owner responsibility for those who forget. The owner responsibility is to maintain an inventory of all required fire resistance rated construction installed to resist the passage of smoke and so forth. And we're adding sections 60241 and 60242 so that the owner will need to keep an inventory of that. This is where non-combustible protection is applied to mass timber. And further down here, the owner is responsible to annually conduct a visual inspection and keep a log of properly repaired, restored, or replaced items. That's new with it. It's the owner's responsibility exists. We've added or are proposing to add those requirements for the protected mass timber. Okay, so we got some other things. There's where the mass timber is used as occupancy separation. The short version of this is that mass timber must be covered with an approved thermal barrier of at least 1/2 inch gypsum wallboard or other non-combustible material. Same thing applies to other occupancy separations. So I've covered the owner's responsibility. One of the things that is unique to this is that as the building construction progresses, standpipes are required to be provided, water supply is required to be present, one layer of non-combustible protection if required. That means in the case of 4B, where unprotected areas are permitted, you don't have to protect them and then remove it later. So required non-combustible protection needs to be applied on all mass timber elements more than 4 stories below the uppermost floor under construction. Exterior wall coverings on all floors more than 4 levels below the floor under construction. And we said levels there because we meant to include mezzanines. If you have 2 floors, each of which has a mezzanine, then the number is 2 floors with 2 mezzanines below the level of active construction need to have the exterior wall covering. Okay, so in the IFC, there further is proposed, for example, standpipes provided during construction, water supply I mentioned, and I just covered those couple of conditions where interior non-combustible protection and exterior protection need to come up to be within 4 floors of the active work floor. So what that means is, as you start out, when you get up to level 6, you need to have 2 levels protected to be within 4 floors of the active work floor. And as you go up, that has to follow along, interior and exterior. Okay, poll number 5.
Sam, I think we're going to skip this one in the interest of time. Do you want to go on straight to the answer?
That's an easy one. The minimum contribution is 2/3 of the required fire resistance rating. Okay. Oh, we're going to talk. Okay. Building sizes. Here's there's a chart that compares 4A, 4B, 4C. Let me just blow through there. Here are diagrams which will. It's a sort of shorthand of what's required. 4C, maximum height in feet is, where'd my cursor go? 85. Maximum number of stories, and this is for use group B, is 9. All the mass timber, with the certain exceptions like concealed spaces, can be exposed. Must be. It's anticipated to be sprinklered. Primary frame 2 hours, floor rating 2 hours, and so on. Okay, type 4B, maximum height 180 feet or 12 stories. There can be partial unprotected area, sprinklered, 2 hour frame, 2 hour floor, 80 minutes minimum non-combustible protection. Because we're under a 180 or 12, then we can have stair and elevator shafts of mass timber or non-combustible. But when we get to 4A, where that may be 270 feet and group B can be 18 stories, sprinklered, 3 hour frame, 2 hour floor, 120 minute minimum protection, and so forth. But the stair towers and elevator hoistways have to be non-combustible construction. Concealed spaces are permitted in each of them, but no exposed combustible material is permitted in any of the 3 proposed types of construction. So let's take a quick look. Allowable number of stories. I mentioned B before. So here you see 18 is the maximum number of stories in any of these 3 new types of construction, 4A, 4B, 4C. 27 occupancy classes with the subcategories. 11% of them are 18. There are more of the classes that permit 3 stories or less than those which permit 18 stories. So we went through, let me back up one quickly. In order to achieve these numbers of stories, it was begun with a look at 4C and increased based upon professional engineering judgment. There were some in many cases the numbers have been reduced. If you look at the H's and the I's in particular, you'll see they're very small, and they were almost all reduced to the same level as is currently permitted in type 4. So H and I was reduced almost all to that level. Existing, here's group B, existing HT, you're allowed 85 feet and 6 stories. The new proposed 4C, you're allowed 85 feet and 9 stories if you're clever enough to fit it in. 4B, you're allowed 180 feet and 12 stories. And in the 4A, fully protected, it's 270 feet and 18 stories. Those are the maximums. Here's the height in feet chart. And remember, well, perhaps I didn't say it yet, but the group decided that 4B, in all ways other than the combustibility of the material, was equivalent both mechanically and fire to 1B. So you'll notice that those numbers are the same all the way down, 1B and 4B. We couldn't do that with 1A because that's all unlimited, and we weren't going there, that's for sure. So we simply increased it mostly by 50%, but in some cases by considerably less. And then area, in this case, we could not rely upon our 4B is equivalent to 1B because 1B is all unlimited. So we took 4C and we increased it by 25%. I'm sorry, HT increased by 25% to get 4C, by 2 times to get 4B, and 3 times to get 4A. Then we went through cell by cell, took a look and said, should this be allowed to stand? Isn't something like H2, isn't that kind of big? And so once again, it's limited to whatever the old HT was limited to. In many cases, all the way down through the H's, and in the I's, you'll find it to be the same, where it's limited to what old HT was limited to. R's, different matter. The ratios applied. So you look at that and you say, gee, sprinklered multi-story 4A, that can be 184,500 square feet. Yeah, it can, but I can multiply that by 3 stories, but then if I'm building an 18-story building, I divide that answer by 18. So I'm going to get somewhere around 30,000 per floor, not 184,000. It's deceiving. Remember the formulae that ICC employs to get building allowable height in areas. And last, well, nearly last is all of our changes listed one by one, including the changes proposed to fire districts, owner responsibility. And a last polling question, which is true regarding maximum height. And I presume that because I'm so far behind, I'm going to just go ahead and answer it.
Go
ahead and put the poll up.
We can actually take this one, Sam.
Yeah. Put the poll up. I've already answered it.
Oh, you did? Oop, sorry, I missed it.
It's a gimme. Let them have it.
Here we go. All right. Looks like everybody answered all of the above. So there you go, Sam.
Yeah. After I underlined it. That's pretty good. All right.
I missed it.
That's okay. Back to you.
Hey, I'll just say we're going to take some questions. Such great information, Sam, and we've got a lot of good questions that came in. So could you talk a little bit about, there was a lot of emphasis on non-combustible protection for these combustible building elements. Can you talk about the ratings and how that's distinguished? For instance, you said type 4C, no non-combustible protection required. You know, what is the safety element then is in the fire resistance rating? How is that taken into account?
All of the building elements have a required fire resistance rating. If you look at table 601, primary structural frame, bearing and non-bearing walls, floors, and so forth, they each have a fire resistance rating. At the beginning of chapter 7 in the IBC, it says specifically that however you determine the fire resistance rating, it has to be based upon E119. So the first and easiest way to accomplish that is by testing according to E119. That's not the only way. And you need to look at those entries up there in the beginning of chapter 7. But essentially, they are all, whether it's calculated or it's determined by fire testing, it's still done with the E119 basis at its heart. And I'll say, we've had calculated fire resistance for heavy timber for decades. That's been used going back many, many years. It's been we've done testing to validate the method. And repeatedly it's been used, and building officials and fire officials are comfortable with the methodology. We've developed a methodology for calculated fire resistance for CLT, for example, and other mass timber. Same thing. It's been validated by testing. Lots of that has been done. The short answer is you either go test the assembly as you intend to use it in an E119 furnace, or you do an engineering analysis and use a calculated fire resistance methodology. The NDS, National Design Specification, that we, AWC, publish is referenced in the beginning of Chapter 7. So you can use that for your calculated fire resistance, and you'll be relieved to know that there's a system in Chapter 16 of the NDS that will let you do that calculated fire resistance.
Thanks, Sam. What about light frame partitions? Questions have come up, in types 1 and 2. I think you can use fire retardant treated wood, non-bearing partitions, and so forth. Why
Yep.
not? Why not in the mass timber, the proposed construction types?
At the mass timber was determined to be mechanically and fire performance equivalent to type 1, but it's combustible. What do we do about the combustible issue? And one of the things that we did about it is no light frame combustible elements, period.
So not even inferring out or anything for walls and so forth.
That's
for
correct.
concealed spaces and so forth.
Well, if I recollect properly, at the end of a long day, I think you're only permitted metal hat channel or resilience strips to fur out. It's in there somewhere.
Yeah, that was a conscious decision you told me earlier of the committee to
yes.
That non-combustible. Yeah.
And frankly, the light frame was removed purposefully at the request of remember, it was a balanced committee, and fire service representatives and non-member attenders of the meetings. In other words, people who were not Tallwood Building ad hoc members, but who attended the meetings, all said, don't allow light frame, period. And so we didn't.
So mass timber or non-combustible. And then,
yeah.
What about the exterior issue? You know, some are asking for exterior walls, how are we going to insulate, you know, wood continuous insulation such as foam continuous on the exterior walls? You know, what about that debate, or what about that issue?
There's no debate. No combustible material outboard. And there are insulations that are non-combustible. That's what you have to go to.
Mm-hmm. Here's an interesting one. Why the Bureau of Alcohol, Tobacco, and Firearms Lab?
There are three. If you remember at the beginning of the slideshow, Paul showed a great shot of that giant slab being craned into place. If I could get that slide back up, I would show you.
You can try. I think you still have control, Sam. There you go.
Yeah, let me see if I can get to it quickly.
Next one.
There it is. Up here at the top, you see that striped thing, that's a hood. They use to collect the products of combustion. That's how we measured the size of the fire, the products of combustion, and so forth. There ain't many people that have got a hood big enough to build a 2 or 3 story condo under. So there actually are 3. NIST has one, UL has one, and ATF has one. NIST was tied up. UL had to use a, how would you say, a hybrid kind of system. ATF had a hood big enough and a lab space big enough. That's how, no other reason. We wanted, let me preface, I wanted to go to NIST to do the testing in their lab, but they could not free up the lab in the time constraints that we had.
Very good. Hey, Sam, was the structure used over again between tests, and how did that work?
Yeah, that's the same structure. We did the first 2 tests on the second story and then replaced the roof panels because it was a lot quicker to do it with that crane. And then we did the next set of tests on the first floor. And it was the same structure through the whole thing, except for the remember the exposed wall test number 3 was done on the second level. So when we did the 2 sprinkler tests, they were done on the first level, and we didn't have to repair the wall. The reason that that was a consideration was we were trying to turn these things around in only a week.
Sam, any personal observations about the committee process, or any surprises, or anything in particular that you think would be helpful to code officials or or designers as they try to sift through these requirements and make sense of them and think of them as a whole package? What would you share with them, about the whole process with the committee?
Look at the fire tests first.
Right.
I was not a fan of this type of construction a decade ago, but that's because I had the same initial impression as probably everybody on this call, and that is, in my mind, I'm seeing 2x4s stacked up 180 feet. That's not what it is. And I've been involved in every fire test in one way or another. And frankly, go watch the fire test. 23 meg fire. It's a huge fire. Real fires in the world seldom grow, maybe 8, 12 megawatts, and we had 23 in most of these. So watch that. Remember that there was in tests 1, 2, and 3, there was no intervention, no firemen, no sprinklers, no nothing. Just set it on fire, let all the fuel that we could cram in there burn up, and see what happened. And what happened was nothing much.
Also, there's a couple documents you mentioned, I think, Sam, that will help people as they approach the code changes if they want to get to them. Do you want to mention those again? I think they're on our tall mast timber page on our website.
Yes, indeed. On the tall mast timber page, there are two. One is not a study guide, but a study guide that suggests the order in which you look at these code change proposals. And frankly, it's the order in which I presented them. That's why height and area was last. The Tallwood AdHoc Building Committee took up the issue of height and area last. We did all those other things, sprinklers, super tall building water supplies, owner responsibility, did all that other stuff first, got done, stepped back and said, wow, that's an impressive package of fire protection. And on top of that, we have all of the typical mechanical structural requirements. That's a pretty impressive package. So there are two. I showed briefly the comparison table that lists type 4A, 4B, and 4C, and it line by line compares what the requirements are for each of those three. Those two documents are up there, and they're valuable tools, in my opinion, in looking at this, because it is a full package.
So I think we can wrap up. And if you have further questions, please go ahead and email them to us. And Buddy or Brian, I'll turn it over to one of you now to close us out.
Well, thanks, Paul and Sam, both of you, for an excellent presentation. And we thank everyone for being here today. We hope to see you later on this month for our next webinar. Have a great day.